Hey gang, welcome back to another day of distance learning. In geometry, we're going to continue on where we left off. We're in a unit called area, which is two-dimensional measurement. We found the area of many figures now, of which I'm going to review all of them today, along with add a new two-dimensional object which we can find the area of. So the objective for the day is to be able to find areas of regular polygons. And so initially, right on the first part of the notes here, I have all the shapes we've done so far, and I'll review each one of those with you before we move into the new information. So the first thing we looked at was a parallelogram. Remember, a parallelogram is a four-sided shape with two pairs of opposite sides parallel. The form for that was pretty simple. It was just base times height, and the base and the height always have to be perpendicular. So I see a perpendicular right here. That must mean that 10 is going to be the base and 3 is going to be the height. So in this one, base times height would be 10 times 3, which is equal to 30 square units. After we looked at parallelograms, we looked at triangles. Triangles, we just said, were half of parallelograms. So their formula was 1/2 the base times the height. Base and height still need to be perpendicular. So I look for a perpendicular over here, and I see it right there. That must mean that 8 is going to be the base, and the height is going to be that 7. So again, if I do 1/2 the base times the height, base is 8, height is 7. So that's going to be, what, 28 square units? Next shape we looked at was a trapezoid. Trapezoid's formula is a little bit more complicated. It was 1/2 the height times base 1 plus base 2. Base and height still need to be perpendicular. So again, I see a perpendicular right here. That must mean that 6 is my height, and then my two bases are going to be 8 and 4. So to figure this one out, again, I would do 1/2 of my height, which is 6, times the two bases, which are 8 and 4. And so when I do that, that works out to be what? 3, that's 36 square units. Then after we looked at the trapezoid, we looked at kites and rhombi. They had the same formula. They were 1/2 D1 times D2. The D stands for diagonals. So those are these things right here. So I have one diagonal right here. Remember the diagonal is bisected in a rhombus. So if this half is 10, that means this half over here is also 10. Same thing with this diagonal. If this half is 6, that means this also has to be 6. So if I use the formula here, it'd be 1/2. The one diagonal, the long one, is 10 plus 10 or 20. The other diagonal is 6 plus 6 or 12. So on that one, this would be what? Half of 20 is 10, so it's 120 square units. So next we'll look at circles. Circles, remember, is going to be pi r squared for the formula. R is the radius of the circle. Over here I have a diameter of a circle is 34, so again I'm going to have to take half of that to figure out what the radius is, so I'll be able to use the formula. So again, the diameter is 34.6, so I'll do 34.6 divided by 2 to get the radius. That's 17.3. So now when I use the formula, it's going to be pi r squared or pi 17.3 squared. So after that, I would just go straight to the calculator. So I'll do pi times 17.3 squared. And I punch it in like that. If I just round the number, I get 940.2 square units. Good on that one. And the last thing we looked at was a portion of a circle called a sector. So a sector, remember, is kind of like a slice of pizza. And that's the last thing we worked on here. Turn like that. To figure out the area of the slice of pizza, remember you take the angle measurement, put it over 360, and then you multiply that times pi r squared. That's the formula. So the x is the angle measurement, which I see in this picture is 60 degrees. So I do 60 over 360. Then I'm going to multiply that times pi r squared, or in this case is that 10. So it'll be pi 10 squared. So then what I do is just plug all that into my calculator. So I would do 60 divided by 360 is that. And then I'm going to multiply that times 10 squared is 100. So it's going to be 100 pi. And I end up with 52.4 square units. So those are all the areas that we've done so far. Parallelograms, triangles, trapezoids, kites and rhombi, circles, and then sectors of circles. So we're going to add to our repertoire today of calculating area. And what we're going to do is we're going to look at regular polygons. Regular polygons, remember, are polygons where all sides and angles are congruent. Examples that you've used before, again, you've looked at a square, that's an example of a regular polygon. All the angles are 90, so they're congruent, and all the sides are the same. So square is an example. We've also looked at like equilateral triangles. Remember that each of their angles was 60 degrees, and all the sides were the same as well. So equilateral triangle is another regular polygon. So next we're going to look at parts of these, different parts of regular polygons, and kind of use a circle to describe those parts. Any regular polygon can have a circle go through its vertices. So I'll stay with the square example. Something like this. So any regular polygon, the vertices are going to pass through a circle. So it'll work with that. It'll work with the triangle that we spoke of. So in triangle. It'll even work with like a well-drawn hexagon. So if I have something like that. Again, each vertex would pass through the circle. And so the parts kind of deal with that. So the parts we're going to look at, first of all, we'll look at, that's going to be your center. So these polygons are going to have centers just like circles have. So that is the center. Then you're going to have this. Now in regards to the circle, that is a radius. So the same radius you've looked at before to find area. But now we're going to apply it to a polygon. So this is the radius. And then a new part that you don't know yet, which we're going to use today, is this guy right here. So if you go from the center perpendicular to a side like this, that creates this new thing. This new thing is spelled like this. You've probably never heard of this before. But that is the word apothem. So the apothem has to go from the center and its perpendicular side. So goes from center, perpendicular to a side. So again, the center is here, the radius is here, this is called the apothem. And we're going to use that in our formula for regular polygons. And the formula we're going to use is area is equal to 1/2 AP. So that's our formula. Now the A obviously is coming from that new word that we just learned. This is your apothem length. Now the P, where that's coming from, that is coming from the perimeter of the regular polygon. Now this formula is good for any regular polygon. Formula works for any regular polygon. That means I could use it on a triangle. That means I can use it on a square. That means I can use it on a hexagon. It works for any regular polygon regardless of the number of sides. So let's see if we can use that. So here I have a regular triangle to start. It wants me to find the area. So I'm going to use area is equal to 1/2 AP. So on here, area is equal to 1/2. Now I'm missing the apothem. I don't even have one drawn in here. So if that's the center of the triangle, I draw an apothem in here. That's my apothem right there. Now I didn't give you the length on this, but we can figure it out. Notice that the apothem, when it's perpendicular to a side, cuts the side perfectly in half. So that's going to be equal to that. And then I have this side right here is my radius. So what I've made now is a right triangle. And this would have to be 6 because it has to be half of that 12. So now, something about equilateral triangles is that their angles are always 60 degrees. So this radius that comes in here is going to bisect that 60 degrees into two 30-degree angles. So now I've created a triangle that has a right angle and a 30-degree angle. Well, I can figure out what this one is by doing 180 minus 90 and 30. Well, that's going to be 60 degrees. Again, they all need to add up to 180. So that means I have a 30, 60, 90 triangle, of which I have the long leg. So remember, I can find the short leg by dividing it by √3. So I would do 6 divided by √3. And then I need to rationalize that. So that ends up being 6 √3 over 3, which is 2 √3. So 2 √3 is my apothem on this one. So if I plug that in as my apothem, the perimeter of this, well, this side's 12, this side's 12, and this side's 12. So the perimeter would be 12 plus 12 plus 12, which is 36. So this is going to be equal to, area is equal to 1/2, 2 √3, and then this will be 36. So then half of 2 is 1, and then multiply √3 times 30, so that's going to be area is equal to 36 square root of 3. If you wanted a rounded number, you could just plug that into your calculator to figure out what that is. Most of the time, don't worry about how I got that. I mean, we did do that before with special right triangles. I'll probably always give you the apothem. 9 times out of 10, I'm going to give you that apothem, so you don't have to worry about that, trying to figure out what that is. So here, again, I have a hexagon. So again, regardless of the number of sides, here I use 1/2 AP on the triangle. I can also use it on the hexagon. So again, I'm always probably going to give you the apothem. So I'll give you the apothem here. Let's put the apothem in here, and let's say that's going to be, say it's equal to 3. So the apothem is 3. So if I want to use the formula now, 1/2 the apothem of 3, and then my perimeter, well, one side is 8. Well, they're all going to be 8. There's 6 of them. So instead of adding 8 6 times, I can do 8 times 6. So then when I do that, that'll give me what? 8 times 6 is 48. Half of that's 24. 24 times 3. So that's equal to 72. I could have done that on my calculator by doing what? 0.5 times 3 times 8 times 6. So that's another way you could have done it, just using your calculator that way. But again, I'll give you this, so you don't have to come up with that. So again, here on number 3, I need an apothem. I'll give it to you at like 6. So again, regardless of the number of sides, I'm still going to use 1/2 AP. So here my apothem is 6. Perimeter, well, each side is 10, and there's 4 sides, so that's 10 times 4. So area would equal 1/2 of 6 times 40. So that would be what, 120 square units. So that's all you got to do for these. This one down here wants you to find the shaded area. I probably won't give you one like this, but I'll try to just give you regular polygons. And again, I'm always going to give you that apothem. And you always use 1/2 AP. So you have homework problems on those. We'll see how you do on those. I'll talk to you later.